Here's my website. I call it TheTruth-machine.com. And this website starts out, it says more concise TOE, that's theory of everything explanation. And what I did is I wrote this book like a few years before these revisions came out. Then I wrote these two revisions here. I'm calling it part one of three and part two of three. And these are like little books I wrote called Explaining the Reverse Time Ordering of Light. Part one is an introduction and prerequisites of digital physics as demonstrated in introductory VB programming language. Let me just show you real quick what this looks like. It's free if anybody wants to go ahead and look at it. All free. I never asked for money. There's no ads. There's no hooks in there or anything like that. I emphasize that this is not mainstream science. However, it is 100% analytical based upon the concept of an informational-based universe. It gets implemented by a very simple algorithm called the theory of everything, T.O.E. The explanation only requires simple integer arithmetic to understand. Several simple VB6 code examples, charts, and graphics are provided to help visualize the concepts. Actual VB code snippets are provided for download and analysis. Please be open-minded to these concepts, which are gaining more and more acceptance by mainstream science every day. And in any case, you can learn VB programming basics here for free. Okay, that was the first book in the series, and it goes through, and I don't want to get too much off on a tangent, but it starts with the basic, most fundamental concept of digital physics. I'm going to not go into it with too much detail, and I want to show you what the second book looks like. The second book is called The Digitized Operation of Light, The Fish in the Ocean. Okay? Now this one takes off from the first book and provides an example here, right here. The example is where there's a fish in the water here, and some light hits the fish, and the light is reflected off the fish, and it goes up through the water. And this indicates the surface of the water right here, right over here. And then it goes into the air, and then standing over the water is me, and here's my eyeball right here. I'm looking at the water. I'm looking through the water at the fish, okay? And I'm asking, where is the image of the fish gonna appear on the surface of the water, Is it gonna appear in the straight line, which would be like through here? Or is it gonna get offset because of the refractive index? That's really what happens, okay? So I'm using this example, and I'm using the concept of density to be indicated by more molecules, more dense packing of the molecules in the water than in the air. And I go through the whole concept of how to transport light digitally, and that's shown over here. I want to just really quick scan through this and show you what happens. In the first tick of time, the fish emits a photon, okay? And when he does that, that inserts a record in something I'm calling the photon queue, which it declares the instantiation of this new photon in the universe. And I do that by storing it in a data structure here, okay? All right, in the next tick of time, the pathway of light starts to show itself. It starts to be emitted. And what it is, it's covering various potential locations of absorption. So right in the first tick of time, it's covering these potential locations of absorption. In the next tick of time, it covers these. So every tick of time, the light is going out one more of these units of space. Now, if you equate the distance of space to Planck distance units, and then if the rate of traversal through these units is the speed of light, then actually what happens is it's gonna cover a rate of one grid location, which is one Planck distance unit per tick of universe time. The tick being equated to a Planck time unit. So if you do it that way, each Planck time unit it advances one more Planck distance unit, and that's really what happens in real life. What I'm doing here, I've digitized the whole matter of the whole affair. Okay, so it keeps. This is how light expands off into space now. Next tick of time, it keeps going off. Next tick of time, it keeps going off, but now it encounters some particles here. Okay. And depending on whether these particles are transparent or absorptive, that decides how the algorithm is going to continue the execution. If they're absorptive, it's just going to absorb it, and that's going to be it. It's going to do something called